Hello everyone, good to see you. Welcome to the Huawei HCIP Open Elder Certification course. I'm the trainer, Peggy. In the previous chapter, we have learned the common service management of Open Elder and introduced the basic introduction principles and usage of service such as Apache, Nginx, DNS, and MySQL. Now, let's learn the second chapter of the HCIP Open Elder Certification course, that is, Open Elder Cluster Application. Now, let's learn the second chapter of the HCIP Open Elder Certification course, that is, Open Elder Cluster Architecture.
Single-host applications are insufficient for today's Internet demands, which has created space for cluster applications. This course describes how to configure tools for high-availability cluster and load balancing clusters, including Linux Virtual Server, LVS for short, HA Proxy, Nginx, and Kplived. At the end of this course, you will understand basic configurations and deployments of LVS, Nginx, HA Proxy, and Kplived, and also basic operations of Radius. First chapter, we will introduce the concept related to cluster. With the development of technologies, we have entered the IT era. More and more people work and live through the Internet. The performance of a single host cannot meet the requirements of a large number of users. Therefore, clusters are born. A deployment of two or more computers used to complete a task. This popularity has grown to better handle the efficiency issue common with single-host deployments. Typical cluster types include load balance cluster, HA cluster, and HPC cluster. Load balance cluster first. Front-end access requests are forwarded to back-end compute nodes based on various algorithms to balance the load of each node. And then the HA cluster. HA clusters ensure that applications provide services without interruption. In the event of a fault, applications are automatically and quickly switched to another node. Final one is HPC cluster. HPC performs trillion operations per second using parallel algorithm and the parallel distributed computing which cannot be achieved by a single computer. Many times, HPC clusters are used in special scenarios. Therefore, let's briefly introduce the load balance cluster and high availability cluster. Actually, common Linux-based load balance cluster software includes LVS, Nginx, and HA Proxy, which will be introduced later. Now we can see that Nginx and HA Proxy both support Layer 4 and Layer 7 load balancing. However, in actual scenarios, they are usually deployed as Layer 7 load balancing. So in the subsequent study, we will learn only the configuration of this type of load balancing mode. And first, for HA cluster. Common Linux-based HA cluster software includes Kplived, Heartbeat, and Pacemaker. Where Kplived is a lightweight HA cluster deployment software in Linux. It is initially designed for LVS and then added with the Virtual Router Redundancy Protocol (VRRP) to implement functions such as cluster heartbeat detection and virtual IP address VIP failover. Heartbeat does not manage VIP failover and outperforms Kplived in managing resources services. Its configuration is more complex. Pacemaker is an open-source cluster resources manager in Linux, applicable to clusters of any scale. It does not have the cluster heartbeat detection mechanism and depends on cresync or heartbeat to implement these functions. In Linux, Keep Alive and Heartbeat are commonly heartbeat mechanism, and both are supported by OpenELDR. Keep Alive is easier to install, configure, use, and maintain than Heartbeat, which is more complex but has more powerful functions and tools. Keep Alive suits small and medium-scale clusters, and Heartbeat for large-scale clusters. Now, after we know the common mode, let's look at the basic concepts in clusters. The first is VIP and address failover. VIP is the virtual IP address. It is configured at the logical layer of the cluster and is not directly associated with the specific server. The VIP usually serves as a bridge between the client and the cluster service. The client only needs to know the VIP, not the IP address of the physical server actually runs the service. If a physical host in the cluster is faulty, the VIP does not affect the service access. Generally, the VIP runs on the active host in the HA cluster. When the active host is faulty, the VIP is automatically generated on the standby host. This phenomenon is called address failover. And from this picture, we show a case of VIP and address failover. When accessing the service, the client only needs to access this VIP address 192.168.31 and 112, and does not need to know the address of server A and server B. Assume that server A is the active host and the VIP runs on server A. Server A provides services for clients when accessing services. When server A fails, the IP address 112 quickly switches to server B. Clients are unaware of this process. When the client accesses service again, server B becomes the server that provides service for the client. VIP and address failover can be implemented because of the heartbeat behavior between hosts in the cluster. Heartbeat indicates that hosts monitor each other's status to determine which host runs the VIP and provides services. If the heartbeat is not coordination, split brain behavior may occur. If the heartbeat coordination is abnormal, multiple hosts in the cluster may think that they should run the VIP and provide services. As a result, multiple VIPs appear and the client side cannot access the services normally. This is the harm caused by split brain. A good HA cluster software can effectively avoid split brain phenomenon. When we introduce specific HA cluster software, we will also introduce how they prevent split brain. And the final concept is proxy. Proxies are generally used for load balancing cluster software. Proxies can be classified into forward proxy and reverse proxy. A forward proxy sits in front of one or more clients, and a reverse proxy sits in front of one or more servers. A forward proxy is like a real estate agent. When a customer needs it, he takes the customer to the server. Reverse proxy is like a supermarket. Each manufacturer is a server. The supermarket puts the products of the manufacturer in a centralized place. Customers can obtain the products they needed directly from this place without directly looking for the manufacturer. And only the reverse proxy function will be introduced later. Okay, next, let's introduce the cluster software, including LVS, Nginx, HAProxy, and KeepAlive.
In this section, we introduce what cluster is, and common clustering software, and common concepts in the clusters, such as VIP and address failover, heartbeat and splint ring, and proxy. In the next section, we will look at the first common cluster deployment tool, LVS. Thank you for watching.